Hey, Scott from BS Games again, and I'm going to show you how the subtraction adder works. This is a tool that we have developed to help young people learn and understand math, addition, subtraction specifically, understand exactly how it works and what they're doing when they're adding, subtracting, particularly with the concept of regrouping. So we set out the board here. The first thing your learner is going to do is generate numbers. We're going to add two two-digit numbers. To point out that we're doing addition rather than subtraction on this one, we're going to set the addition die here. Then we're going to figure out what numbers we're going to use. The pre-teaching that you'll need for this is just so that the children understand that these blue counters each represent 1, and that red counters represent 10 blue counters. And they'll get more of that as they go. Everything is color-coded to help them figure that out. So I'm going to generate my first number. So I roll a 3 and a 9. Okay, so that is 39. Red die goes on the red spot, blue die goes on the blue spot. Now we're going to fill up with counters our actual representation of the numbers. So 3 red ones and 9 blue ones. That's quite a lot. So we're going to put all these on here. So this provides a very tactile and kinesthetic experience, whereas the students are moving the pieces around. There you go. Gives them something to do and makes it feel a lot more like a game, which definitely increases the involvement and the engagement in the process. Now, to verify what we have here, that this number actually represents, we can count with the students. Remember, reds represent tens, so we're going to count it this way. 10, 20, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39. So that represents 39. Then we're going to roll to see which number we're going to add to this. Oh my goodness, I'm rolling some big numbers today. So 8 and a 9. Okay, so we're going to put down 8 of these red ones, 8 of these 10s, right? Because 80 is 8 10s, and then 9 1s. Okay. And again, once the students have done this a few times, they'll really start to get the idea and the concept. But once again, because we're starting out, we're going to prove to them this number represents the number with these counters. So we'll go over it: 10, 20, 30, 40, 50, 60, 70, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89. So here's the procedure to add these together. Here we have the two numbers we're adding together. Then there's an equal sign. So this is where our solution is going to be, on this side of the board. So in order to add the numbers together, we start with the blue ones. So we're going to take all our blue counters and move them to this side of the board. First with these ones, and then these ones. Okay. Oh, perhaps already you can see that there's a problem here, is that each number space only goes up to 9. So what are we going to do? Well, there's a little helpful banner here. We'll tell you what to do. We have too many. They overflowed. So we take off 10 of the ones and we trade them for a 10. Okay, so what do we have here? Let's add them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we're going to take 10 of these, 2, 4, 6, 8, 10, and we're going to trade them for a 10. Now, of course, the 10 can't go here because that's not where 10s go. That goes here. So remember we had 18? Let's prove that we still do. 10, 11, 12, 13, 14, 15, 16, 17, 18. So the number is still represented. It's still the same amount, even though we're representing it in different ways. 18 ones is the same as a 10 and 8 ones. So here's a good example of place value and understanding the concept of groups of 10. But we're not done yet because we still haven't added our 10s together. So same as before, we need to bring everything over to this side because this is the solution side of the board. So all of these go over here. And oh, it looks like we're going to have the same issue. What are we going to do? Well, we have too many. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 10s here, so 120. So we're going to take 10 of these away. Well, not so much taking them away. This part's important. We're actually just trading them. right? Because we can take, that's 9, 10, and we're going to trade them for a green one. Because a green one is 100. So if we counted those 10, we count 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. That's the same as having one green 100. Okay, so now we're done. So what does this represent? Let's have a look. Well, let's go find our green die. How many hundreds do we have? We have one green one, so we're just going to put a green one there. How many tens do we have? We have 2, so we're going to put a 2 here. And how many blue ones do we have? We have 8. There we go, so there's an 8. So what number do we have? Okay, it's this point that the student can look and say, well, we have 128. That's the answer. That's 39 plus 85 is 128. And we can show it to them, how it's broken down. 100, 2 tens, and 8 ones. That's how we get that answer. So I found that this is very useful for your beginners, for your learners. You can jump straight to the standard algorithm and just show them the steps. But I have found that even in the higher grades, that just going for the standard algorithm and showing them how to figure it out doesn't really inspire a lot of understanding in how the numbers work. I've had students in my classes in grades 6 and 7 who've had some trouble with some of the concepts of the basic addition and subtraction simply because they were following the steps that they were taught without understanding what's going on behind the regrouping. The fact that we are taking a group of 10 ones and just changing it into a single 10, and that's why that number gets higher. Right? That's like carrying and borrowing, as it's been called in the past. So that's addition. We could do a subtraction as well. Move these off to the side. Take these out of the way. Subtraction works slightly differently, and I'll show you how. We're going to roll our numbers. Again, we'll do 2 digits, but what the heck, let's do something advanced. We rolled a 47 and a 37. So the thing to keep in mind here, the student needs to know, is which one of these is bigger. Well, this one has 4 tens, that one has 3 tens, so this one's bigger. Okay? And this one only has 3 tens and 7 ones. I think I said tens, I meant ones here. So just for getting some regrouping in here, you know what I think I'll do is I'm going to just change this to a 6 just for illustration purposes. So same as before, we populate the one up here. Okay, so we're going to put 4 tens, and we're going to put in 6 ones. Okay, and we can show that this is what we have. 10, 20, 30, 40, 41, 42, 43, 45, 40, I skipped one. 41, 42, 43, 44, 45, 46. Now, instead of putting counters here, because we're not adding them together, we're actually taking them away. So we're going to take from the top and move it down to the bottom, and whatever we have left over is going to come over here to be our answer. But already there's a problem. We have to take 7 away, but we only have 6. So how are we going to make that happen? Well, here's what we can do. We can trade one of these 10s for 10 ones. So I'm going to take one of these aside, and I put in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? All right, so I know what you're thinking. This is a problem. We got too many here. But I think it'll be a temporary problem. And if we look at it, we'll recognize that we still do have the same value. 10, 20, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46. So once again, it's still the same value. It's just being represented in a different way. And this, I feel, is very much an important part of math and an early understanding for students to get, is that what you're doing when you're in fact doing math is just representing numbers in different ways. But now we can continue on. So now we can take 7 away because we have enough here. So let's move 7 down to here. 1, 5, 6, 7. Put that there. And then the same thing here. We're taking 3 away from here. So we can move those down. And we can do that because remember we set it up so the bigger number would be on top. as you need to for subtraction. Then whatever we have left up here gets moved over. And we count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9. We put a 9 here. So now we realize that 46 minus 37 equals 9. And that's how we get our answer. Regrouping shown explicitly there so that the learner can get a feel for what's going on. So to start with, after explaining to a student how to work with this, you can just leave them to it. I also even suggest maybe leaving them with a calculator so they can double check to make sure they get it right. Because, you know, they like pushing the buttons and playing with the calculator as well. So they'll go through the process, use their calculator after to make sure they got the right answer. If they didn't, they can start it over to see where they went wrong. From there, you can start having them write down their questions and their answers. So they'll just write down the two numbers that they rolled, whether they're adding or subtracting them, and what they got as a response. Then they can hand that to you after, and you can go over them and double check them. Any that you found were incorrect, you can revisit with the adder and say, how did we do this one? Because that one ended up being incorrect. And you can find any errors or misconceptions that they were making during the course of that. From there, you can move on to showing them how to write it down with the regrouping illustrated on their sheet. So there you're getting into the writing of the standard algorithm where they'll do their question, and anytime they do some regrouping, they can indicate by crossing off the number when they take one of those groups of 10, for example, and changed it into more ones so that they could subtract. Or they can indicate when they took off 10 ones and then moved one over to the tens place. And from there, they can roll the dice to create questions and answer them on their own before using the adder, and then maybe afterwards using the adder if they didn't get the correct answer or if they don't understand how to do the question. So you're eventually going to have them work from using it entirely to do the question to get the answer, to have them moving away from it so that they'll no longer need it. So sort of a gradual release of needing all the scaffolding and the extra help until they're able to just write down the question and figure out the answer from there. So the great appeal, I feel, is the layout. We have dice, we have counters. It's very game-like, so children will enjoy sitting down and playing it for a while and keep them involved. They're interested in seeing if the answer they get is correct. So it provides a bit more of an immersive and interesting experience, which when you want students to sit down and have a good experience and have a good time and a good feeling about doing math, and prevent maybe some later math anxiety as they grow older, which will prevent them from getting the higher level, more difficult concepts. So there you go. There you have it. There's a subtract and adder. If you do have any questions, you can contact us for sure. We are at contact.bsgames@gmail.com. You can check out our website for more images and information about the subtract and adder. That is bsgames.ca. And you can also just leave comments in the channel below there, below the video. So hope to hear from you. Thank you very much.